right, guys, now we're going to go over Quarter 2 Benchmark Study Guide Part 2. It says Abby's in the EA diving team. On the EA diving team, her coach graphed her dive from jump to splashdown. The graph shows her height in feet. So we have her height down here. And as a function of distance in feet, so here's the height or distance, her coach stated that her domain was from 0 to 22. Her coach is incorrect. Please explain the mistake that her coach made. So why don't, and then part B, we have to find the domain. So why don't we do that first, okay? The domain, remember, is the x to the y. So that's, not the x to the y, the values of the x, which is this. So the graph starts right here, which is at x equals 0. And it goes to here. So what is the mistake here? Well, it doesn't go to 23. He must have given the range because this goes to 23. See, it goes all the way up to here. So we're going to say that he gave the range, not the domain. Or you can say that he put the y values, not the x values. So let's give the correct domain. The correct domain would be from 0, like we just said, down here, right here, and it goes all the way to here, which we'll say is 8. And what does domain mean in relation to the context? It means the x values that the graph covers. Okay. It says the function shown in the graph describes the relationship between x, the number of thousands of smartphones a company makes, so that is it's down here, and f of x, which is basically the y, which is the average production cost per smartphones in thousands of dollars. That's this. Select all values that are in the domain of the function as shown on the graph. So let's see, the domain, that's the x values. So first one, 0. Is there an x value for 0? No. There's not, so we're not going to select that. What about -5? That's going to be way back here. Is that on my graph? No, it's not. What about 50? Sorry about the bell. So let's look at x equals 50. That's right here. It is on my graph, so I'm going to select that one. What about 8? X equals 8, somewhere's like right here. And like it is on my graph, so I'm going to select that one. 9.022225. Well, that's going to be like right here, which is on my graph, so I'm going to select it. And the last one is 22.75. It's going to be somewhere like right here. It is on my graph. So that is the answers. Adam deposited $20 into his savings account at Regions Bank. At year 10, how much money does Adam have in his savings? So they gave us a graph. So we really just need to know what is the x and what is the y in this situation. So the y is the end amount, which is what we're looking for. So time is going to be my x. So that's 10 is my x. So what I'm going to do is look where my x is 10 is right here and go see what that is. And it is about $80. Remember, this is the equations that were like f of x equals a 1 plus or minus r to the t. So this was my a, my t was 10, and I just had to find what the f of x is going to be. The value of a car changes according to the equation. P equals 10,000 times 0.88 to the t. So it's the same type of equation we're just working on. P is basically f of x, where P is the value of the car in dollars and T is the time. In the equation, the number 10,000 represents which one? Does it represent growth rate, initial value or final value. So remember, this is the same thing as f of x equals a times 1 plus or minus r to the t, or f of x equals a times b to the t. B is 1 plus or minus r. So that's important. So 10,000 is where A is. And do you remember what A represented? The initial value. The value of the car is increasing or decreasing. Well, that depends on B. Is it between 0 and 1, meaning did we subtract R or did we add R? Well, it's less than 1 because it's 0.88. That means it is decreasing. And what is the rate? Well, if 0.88 is B, and that's 1 plus or minus R, it's minus R, so 0.88 is equal to 1 minus R. So what is R? Well, let's solve this. Subtract 1 from both sides. I get negative 0.12 equals negative R. Divide by negative 1. Get rid of that negative. And we get 12 positive 0.12 is equal to R. But they're in percent, so to get a decimal to a percent, we multiply by 100, so R is 12%. Ford Motor Company has two different banking accounts. The value of the company's first account is shown in the table below, where T represents the number of years since the account was first opened, and A of T represents the account value. So the first thing they want us to do is determine the rate of change. So what they're trying to figure out is what are we doing from here to here? Okay, what are we multiplying by? We know that because it is a exponential function, it's talking about accounts and time. We know that it's going to be a multiplication. So what do I have to multiply this by to get this? To figure that out, we're actually going to divide 16,200 divided by 15,000. So again, all I did was 16,200 divided by 15,000. And I got 1.08. So that means that this is my B, 1.08. So the equation was f of x equals a times b to the t, or f of x equals a times 1 plus or minus r to the t. So I can see this is bigger than 1, so it's plus r. And this is my b, because this is what I'm multiplying by every time. Because 15,000 times 1.08 gives me 16,000. 16,200 times 1.08 gives me this, times 1.08. So that's what my b is. So if 1.08 is equal to 1 plus r, we just subtract 1 to get our r. And we get 0.08 equals r. Multiply that by 100. And we're going to get 8%. So the rate of change is 8%. But that brought us up how much per year? It's a different amount each time, so we're just going to say 8% per year. All right, so the next part says, one second. All right, the second part says the value in dollars of the second account is represented by, and it gives us the function, where T represents the number of years since the account was first opened. Determine the rate of change from T equals 0 to T equals 5. Actually, I'm just reading that says I want some money per year. So this first one that we did up here, we said that it was 8%, which it is. But to see the rate of change, we would subtract this from this. So 22,039.92 minus 15,000 is 7,039.92. We're going to divide it by the number of years. It's 1, 2, 3, 4, 5. And that's going to give us the average rate of change, which is $1,407.98 per year. Okay, so bottom one, we have to plug in t equals 0 first. So we have a of 0 equals 35,000 times 1.05 to the 0, which anything but 0 is 1. It just gives us 35,000, sorry. Then we're going to plug in t equals 5. Put that in our calculators. We get 44,669 and 85 cents. So to determine the rate of change, we're going to subtract this from this, and we get 9,669 and 85 cents. And we're just going to divide that by 5. And we get 1,933 and 97 cents per year. All right, this question is one of the relative frequency questions. It says Miss Brown's kindergarten class were categorized based off if they were a boy or girl and by their favorite color in the 2A table. Which of the following statements is true? The percentage of students who like red or blue is greater than the percentage of girls. So if you remember, all we had to do to find percentages, we had to get the relative frequency, which means divide by the total. So the first one, we have 4 divided by the total is 20, so that's 0.2. And then we have 3 divided by 20, 0.15. 7 divided by 20, 0.35. 2 divided by 20, 0.1. 1 divided by 20, 0.05. 0.15 divided by 0.15, 0.35. 10 divided by 20 is 0.5. 9 divided by 20, 0.45. 11 divided by 20, 0.55. All right, so now these are the decimals, but we can compare decimals just as we could percents, or we can put them in percents. So students who like red would be 0.35, or blue. So blue is 0.5. So red or blue would be these together, which is 0.4. That is not, you can't even read that. Is greater than the percentage of girls. So girls is going to be this right here, which is 0.55. Is 0.4 greater than 0.55? No. Now see, I just compared decimals, but we could make that percent multiplied by 100. This is 40%, and this is 55%. So you could compare it either way, it doesn't matter. Okay, so the next part, let's says the percentage of boys who like red, so that would be the 0.2, is less than the percentage of girls who like green. So green of 0.05. Which one's less? This is. So the girls who like green is less, so that's not true. The percentage of girls who like red or green, so let's see, girls who like red is 0.15, plus girls who like green is 0.05. So when we add that together, we get 0.20. And they're saying that's less than the percentage of boys who like blue. Boys who like blue is 0.15. Is the 0.2 less? Yeah. So hopefully the last one's true. It says the percentage of boys who is, there must be something missing, but the percentage of boys, okay, this is supposed to say boys who like blue. So boys who like blue, that's 0.5, compared to the girls who like green or blue. So, I'm sorry. Kidding. Okay, if it's blue, 0.5, it's greater than the percentage of girls who like green or blue. So girls green or blue, that would be 0.05, 0.35, 0.40. But I did this part wrong. The boys who like blue is actually 0.15. So this is not true. But I read this top one wrong. Because it said the percent of students who like red or blue. So if this thing that's 0.35 plus 0.5 is greater than the percentage of girls. The percentage of girls is this right here. So 0.35 plus 0.5 is 0.85, and that is greater than 0.55. So this is true. Sorry guys, I can't read. The graph shows the number of air conditioning units in the thousands that run for every day we get in the winter. Determine whether each statement below is true or false. So it says there is a linear correlation between the two variables as the data points fit closely along the line of best fit. So if I drew a line of best fit, it would probably be through here. And they are actually really close, so we're going to say true. There is a positive correlation between the two variables because as one variable increases, the other increases. Well, it's like as x is increasing, y is actually going down. So this is false. There is a causation between the two variables. Well, it says the number of air conditioning units in the thousands that run for every day we get in the winter months. I would not say that's causation. There's causation between the two variables because as one variable increases, the other one decreases. That has nothing to do with causation. It's false. Two communities, community A and B, have age distributions shown below. Which statement about the distributions are true? Community A has more people, but the medians of both communities is the same. Well, that's not true because the medians aren't the same. So, community A has both a larger mean and median than community B. Well, let's talk about the spread. So community A is symmetric which means the mean and median are about the same. Community B is skewed right because the information is mostly on the left. So that means the mean is to the right of the median. So community A does not have both a larger mean and median. It probably has about the same median, but community B would have a larger mean. Community B has a smaller mean, but both have the same median. Okay guys, sorry, I was interrupted and I actually just realized these weren't labeled and I did one of them wrong anyway, so we're just gonna start on these. All right, so it says that community, this is supposed to be A, has more people, but the medians of both communities are the same. So the medians of these are about the same. And when we add these together, if you add up, like this is 10, this is 45, this is 70, 75, so on and so forth, you get 315 over here. And you get 238 over here. So it is actually more. And medians are the same, so this is correct. Right, number 9 says Annabelle is comparing the prices of 2 restaurants. The results are graphed on the dot plots below. She doesn't want to spend a fortune eating out. So which restaurant has the cheapest average price? So we're getting the average, we add them all together. So for this one, I'm going to add 10 plus 15 plus 16 plus there's 3 18s. There's 2 19s. And there's 2 20s. So we do that. All right, so that equals 173. And then we're going to divide by how many pieces of data we have, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we get 17.3. That's the average for restaurant A. So for restaurant B, we're going to add this together. So we have 10 plus we have 113, 3 15s, 116, 117, 118, 119, 120. We're going to add those together. We get 158 divided by how many pieces of data or dots there are, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we get 15.8. So which one has the cheapest average? Restaurant B. All right, and the last one. The table below shows the data for a linear function and exponential function. Explain how you know which is which. So we have to look at what's happening between the two. So to get from 6 to 18, I can multiply by 3 or add 12. From 18 to 54, if I add 12, I do not get that. But I can multiply by 3. So that means, let me write 3 twice. So that means that g of x is exponential. So I know g of x is exponential because it has a geometric sequence. So I'm pretty sure that is a linear one, but just to make sure, to get from 105 to 120, I add 15. To get from 121 to 105, I add 15. See? So it's f of x is linear because it has an arithmetic sequence. Okay. Now they just want us to determine f of x and f of g when x equals 6. So go through the next one. So I have to do 54 times 3. That gives me 162. On the other side, I just have to add 15. So 135 plus 15 gives me 100.